Next, we're going to take a look at a specific real-world example of a piecewise defined linear function that's inspired by a common household utility bill, in particular, the electric bill. So we previously did an example of a more simple electric bill with just a linear energy usage rate. Now we're going to look at something that PG&E does on the West Coast, that's Pacific Gas and Electric. It's basically the electric company out here in California. And they basically have a tiered structure for their energy charge. First of all, just in case you're unfamiliar with the term, energy is billed in units called kilowatt hours, lowercase k, capital W, lowercase h. KWH like that, so kilowatt hours like this. What are kilowatt hours? Well, it's kind of an awkward unit. It would be more sense if they build electric usage in megajoules. What's a joule? But joules, so megajoules, MJ. That would be probably better. If they could go back in time and redo it, they'd probably switch to megajoules. But everybody does kilowatt hours. Kilowatt hours is kind of like measuring distance in mile per hour seconds, right? Mile per hour is your speed and seconds is the time. So it's just a simple way of multiplying speed by time to get distance. So if you're traveling at 60 miles per hour for 5 seconds, you just traveled 300 mile per hour seconds. Right, that doesn't make any sense. Why not convert into miles? So it's the same sort of deal here, because 1 watt is equal to 1 joule per second. So the joule is the unit of energy. So when you measure energy, it's always measured in joules. Right? So watt is a unit of power. So this is power. And then joule is the actual energy. So you can have so many joules of energy stored in a battery, or it can, to lift a book to a certain height might require so many joules of energy to do that motion. So, or a car going down a highway has a certain number of joules in kinetic energy that would be dissipated into the environment if it were to slam on its brake and come to the stop. So joules the joule is a unit of energy. Watt is a unit of power. Now, power means energy per unit time. So watts tell you how quickly you can deliver the power. So you can have this much energy, and it can be delivered like that, and you're going to have a pretty, abrupt, violent pow, right? But that same amount of energy delivered over an hour, it's going to be like just low energy, not coming through very fast, right? So that's why, light bulbs have a rating in watts, because it's how much energy per second that's being burned and consumed by the light bulb. To say that, 500 joules will go through this light bulb is kind of meaningless. Well, how long does it take? 500 joules in 1 second, it might blind you. 500 joules over a year, you wouldn't even see it. It's so dim, right? So it's energy per unit time. So kilo, of course, means 1,000. So a kilowatt is 1,000 joules per second, right? So a 60-watt bulb is going to be 60 of those 1,000. So a 60-watt bulb is going to be equivalent to 0.06 kilowatts. Now, the kilowatt hours comes into, you take the rate at which you're using energy and multiply it by time to get how much energy was used. It's kind of like saying mile per hour seconds. I was driving 50 miles per hour for 3 seconds, so I traveled a distance of 50 or 150 mile per hour seconds. Of course, nobody ever says that. Only in electric companies come up with this sort of thing where everything's measured in kilowatt hours, but it's the same deal. It's joules per second times hours. To convert this into joules, well, 1 kilowatt hour is equal to 1,000 joules per second, so that's a kilowatt, times 1 hour. Now we can multiply this by 1 hour and 3,600 seconds. So 3,600 seconds is equal to 1 hour. So 3,600 seconds divided by 1 hour is equal to 1. So I just multiplied this by 1. But now you see the seconds cancel out, the hours cancel out, so we're left with 3,600,000 joules. So 3.6 million joules, or we can just say 3.6 megajoules. So we just derived this unit conversion. 1 kilowatt hour is equal to 3.6 megajoules. So that's why I said billing in megajoules, it's a simple conversion. It makes more sense because that's the actual energy you consume. Everyone gets confused with kilowatt hours, but there's no need to be. You know, for this example, you can just think, okay, kilowatt hours is a measure of how much energy that was used, or how much electrical energy that's used during the month. Electric bills are given out monthly. And PG&E, so just PG&E, has a tiered structure for energy costs. So that means everyone has what's called a baseline quantity. So up to the baseline, you get one energy rate, so many cents per kilowatt hour. Every kilowatt hour costs so much money, right? So many pennies are going to be paid for 1 kilowatt hour of energy. By the way, we said a 60 watt light bulb is basically 0.06 kilowatts. So that's the power consumption, 0.06 kilowatts. Just converting from watts to kilowatts with that factor of 1,000. So therefore, if you leave a 60 watt light bulb on for 1 hour, you've consumed 0.06 kilowatt hours. So you just multiply, if you have an appliance that's 11,000 watts and you run that appliance for 1 hour, that's 11,000 watt hours or 11 kilowatt hours. You see how that works? You just multiply the wattage by time and then convert to the kilo. So there's a baseline quantity which can be different for different regions and based on the season. But I just looked up my PG&E bill, and I'm currently have a baseline quantity of 330 kilowatt hours. So that's the baseline amount that PG&E has set for me for my electric bill. And then everything else follows from the baseline quantity. So there are 4 tiers in the PG&E bill. Tier 1, Tier 2, Tier 3, and Tier 4. And so basically, based on how much energy you use, you get a different marginal rate. So Tier 1, you're charged 13 cents per kilowatt hour. And this is for, let's say B is the baseline quantity. I'll just say use a variable. And this is if you're from 0% to 100% of B. Let's say baseline. So if you use up to your baseline usage of 300, in my case, 330 kilowatt hours, I'm billed at 13 cents per kilowatt hour, up to 330 kilowatt hours. After 330 kilowatt hours, something else happens. I'm suddenly billed at 15 cents per kilowatt hour. So this is from 100% to 130% of the baseline. So your first 30% over baseline, it's kind of like a little bit of a warning. The price goes up a little bit, and that's just for your first 30% above the baseline. After you reach 30% over your baseline, so baseline quantity, think about it like, this is what they say you should be consuming as an individual. If you consume enormous amounts of energy, you're going to pay more to have that extra energy. And so first of all, 100%, you have the low rate. 100 to 130%, it's a little bit more, not too much, just 2 cents more, just to kind of like a little bit of a grace period where the rate goes up a little bit, but not too bad. And then after 130% of your baseline, we're at 32 cents per kilowatt hour. And this is from 130% to 200% of the baseline. And then tier 4 is over 200% of baseline, and then that's charged at 36 cents per kilowatt hour. And sometimes those rates might change too, but that's the general structure, that there are 4 tiers, and for tier 1 usage, it's 13 cents per kilowatt hour. Tier 2 usage, it's 15 cents per kilowatt hour. Tier 3, 32 cents per kilowatt hour. Tier 4, 36 cents per kilowatt hour. And let me say that these are marginal energy costs, marginal rates. In other words, let's do the 330 kilowatt hour baseline. Let's say somebody uses 331 kilowatt hours. Does that mean that they have to pay 15 cents on all 331 kilowatt hours? So your first 330, suddenly you have to pay an extra 2 cents on all of that energy you've already bought? No, it's just the marginal rate. So in other words, your first 330 kilowatt hours is always billed at 13 cents per kilowatt hour. Only that 331st kilowatt hour is billed at 15 cents. And then your 332nd kilowatt hour and 333rd, and so forth and so forth. So basically they say how much of your, if you spent under 330 kilowatt hours, if you consumed less than 330, less than baseline quantity, it's just how much you use times 13 cents. If you're in tier 2, so if you've used between 100 and 130%, so for example, if you use 120%, well, they first take the baseline usage and charge you 13 cents per kilowatt hour for your baseline. And they take that off of how much you used. And they say, okay, how much over that did you go? Okay, 20% over, so they take that amount of energy and charge it at 15 cents per kilowatt hour. And then the thing continues as we go. The same sort of marginal rates apply for federal and state income tax. So sometimes you might hear people say that, oh, I have to come up with a deduction to get into a lower tax bracket, because if I'm in this tax bracket, I'm going to be charged at 25% tax instead of 15% tax. Coming up with that extra dollar deduction, or the $10 to, if you're just a little bit over into the 25% bracket, it's continuous. It's a continuous function. It won't make a big difference, because when you're in the 25% bracket, it just means that some of your income is taxed at 25%, just the amount over that threshold. Your first, however much money, is still taxed at 10%, and it always will be. It's when your higher income's taxed at 25%, your first $6,000 they don't go back and re-tax that at 25%. It stays taxed at 10%. And then the next amount of money is taxed at 15%. Then in the next amount is taxed at 25%. Then the next amount is taxed at 28%, and so forth. So it's progressive like that. Everybody pays the same amount of taxes on their first $30,000. Everyone pays the same on their first $10,000. So people talking about a 39% tax rate, well, that's the marginal rate, which is like over 300,000 some, you're paying 39%. Now, if you make $100 million, your first $330,000 is pretty small. So essentially, you're paying really close to 39% tax rate on. But your first $10,000 really is only at 10% tax, or your first $9,000 or whatever the cutoff is. So you still get the lower rates like everyone else does. So doing something where you're trying to get into that lower rate, it doesn't make a difference. It's better to have more income. So what? It's marginally taxed a little bit more. You're still bringing that extra income. It doesn't go back and retroactively apply. The rates don't retroactively apply to your previous income that are at those rates. Just like with this electric example, this 36 cents per kilowatt hour, it doesn't mean that if you're over over 660 kilowatt hours, that all of that's taxed at 30 cents per kilowatt hour, is only the energy used above 660 kilowatt hours. If you're at 661 kilowatt hours, it's only that 1 kilowatt hour above 660 that's taxed at this rate. So that's how the margins work. So our job now that we've stated this problem, is to, and we've talked, I'm trying to use my pen on, it wasn't working on my notepad. That doesn't work. The pen on this works, not notepad. I'll remember that. Just trying to write over there. Okay, so it's like, why isn't this working? Okay, so let's come up with C of Q. Let's use some, not f of x gets boring. So C is the cost of energy. And then Q is the quantity. So C is measured in dollars. Quantity of energy, this is in kilowatt hours consumed. So we want to come up with a piecewise defined function that tells us the cost of basically how much we owe the electric company as a function of how much electric we used in kilowatt hours. All right, so that's C of Q. All right, so I'm going to try something. Oh, awesome. Okay, so I can actually pick that up and move that. That's a very cool trick. So let's delete this. And let's take this piece. Oh, crap. Copy. Here we go. Okay, so that's cool. Okay, so we get 0 to 100, 100 to 130, 130 to 200 over 200. That's up there. A little more space. Let's not delete that. Let's keep that stuff up there. Okay, so first of all, we're going to write our function, C of Q. First of all, we're going to need to figure out the 4 formulas, and then also our 4 intervals. So the baseline is 330 kilowatt hours. So the first formula is going to be valid for Q on 0 to 330. Next one is on Q going from 330 over 330 to, so for this one, it's 130% over. So 1.3 times 330 is 429. Right, so the third one, Q goes from 429, so that's 130% more than the baseline, to 660, which is twice the baseline. And then the fourth one is 660 to infinity. So anything over 660 kilowatt hours. So those are the 4 intervals. So first goal here was to take those percentages and convert them into actual amounts of energy usage. So now if your electric bill is 513 kilowatt hours, I know, okay, 513 is on this interval, so we'll use formula number 3. So that's how kind of this piecewise defined function lookup goes. If your electric bill is 362 kilowatt hours, okay, that falls within here, so I'm going to use this formula. So next step is to get a specific formula for each of these 4 intervals. First one's easy because we're starting out with 0 and we're going to add on 13 cents per kilowatt hour. So that's a slope of 0.13. So the first formula is just 0.13 Q for Q on this to that. Okay, so it's makes sense, right? If we're at 0 kilowatt hours, it's a 0 charge. 1 kilowatt hour is 13 cents. 1 times 0.13 is 0.13. 2 kilowatt hours is 26 cents, and it increases linearly. So the way to do the next one, and so this is kind of like just about attacking the problem, looking at it, and using what formula solves this problem. It's hard to dig up a formula. Always write down the formula, draw a picture, make a table, get a visual understanding of what's happening, and then you can come up with your own formulas. Now the important thing here is that this is continuous. So if I use this formula at 330 kilowatt hours or the next formula, it has to give me the same amount, same charge, right? So basically we can use this formula as the starting point for the next formula, right? Because once we're at 330 kilowatt hours, 330 times 13 cents, our bill is $42.90. So we're going to start off with $42.90 plus 0.15. Let me scoot this over to the left a little. $42.90 plus 0.15 Q. How many of you thought that this is the answer? If you think this is the answer, you're wrong. But a very common mistake. And the reason is that 42.9 is how much energy we used at 330 kilowatt hours. This Q is counting from 0. So at 330, this formula doesn't give you 42.9. It's 42.9 plus 330 times 15 cents. Basically, you're being charged twice for those first 330 kilowatt hours. To rectify that, we subtract off, in parentheses, 330 from Q. So now it's 15 cents times the amount over 330. So if we're at 330 exactly, 330 minus 330 is 0, and we're just at 42.90, which agrees with this formula. So this is just the amount above 330 kilowatt hours. So the second formula is $42.90 plus 15 cents times the quantity Q minus 330. Now we continue in that matter. Using the second formula, we can figure out what the utility charge is if we use exactly 429 kilowatt hours. In other words, if we're exactly 130% above baseline usage. In that case, we just have to plug in 429 in for Q to see what the electric bill is equal to. So it's going to equal $42.90 plus 0.15 times the quantity, 429 minus 330. So that's 99 kilowatt hours above baseline. And the charge is $141.90. And this is where you always want to do what is called a reality check. Reality check, so basically, let me write this down. C of 330 was $42.90. C of 429, I got 141.90. Reality check is, does your answer make sense? You always want to be, even if you're not explicitly saying it, you always in some part of your mind want to be thinking, okay, does my answer make sense? Something's fishy here, because 330 kilowatt hours only costs $40. For an extra 30%, it costs an extra $100 when the rate's not that different. I mean, 13 cents to 15 cents. Something's wrong. 330 times 1.3 is 429. Okay, 429 is the right number. That's only 30% over. Maybe I typed it in wrong. 429 minus 330, let's do it carefully, $99 times 0.15, 1485. I see. Somehow that 0.15 I must have left that out when I typed it in. But you see, I caught the mistake because I was always thinking, does this make sense intuitively? Like if your first 300 only costs you $40, why would the next 100 cost you an extra $100? it just doesn't add up, right? So that's 1480. Okay, so I left off the 0.15. So then I add $42.90, $57.75. So the electric bill, if you're 130% of baseline, it's not $141, it's $57.75. Okay, that I believe, because at baseline your electric bill is $43. If you use an extra 30%, it goes up to $58. Okay, that makes sense. It doesn't make sense to go up to $140. So we start off at 57.75 plus the marginal rate is 0.32 times the amount over 429. Right? Q minus 429 tells me how much into tier 3 I am. How much should I go over that 130% threshold of 429 kilowatt hours? So this is the starting bill. This is basically 57.75. That's the ending point for the previous function. And then I add 32 cents per kilowatt hour times the number of kilowatt hours over 429. So how many excess kilowatt hours do I have? And then we do the same. We rinse, wash, repeat, however you want to call it. We do the same sort of, deal. Let's evaluate this at 660 kilowatt hours, see what the bill is at 660 kilowatt hours, and then, add the new marginal rate to that. So formula 3 at 660, C of 660, given by formula 3, $57.75 plus 0.32 times parenthesis 660 minus 429 end parenthesis 131.67. 131.67. Now note that this is just another 70% of baseline, and yet we went from about $60 to about $130. So that's about a $70 increase for using, like 200 kilowatt hours. So, but that makes sense because the rate is over twice as what it was before, right? So the rate has gone up considerably, so it makes sense that it's suddenly more expensive for those at next 200 kilowatt hours. So for the final one, it's going to be 131.67 plus the final marginal rate 0.36 Q minus 660. Squeeze that in. So basically, it's $131.67. That's the cost of your first 660 kilowatt hours. Plus 36 cents per kilowatt hour times how much in excess of 660 you are. If you're at 661 kilowatt hours, that 36% rate right here only applies to that 1 kilowatt hour you went over the top. So that is, so that's the piecewise defined function. And then we can actually, instead of having this 42.9 plus 0.15 times parentheses, instead of doing that, you have to love technology. Okay, it's not exactly what I wanted. Okay, now let's, okay, I guess that works. Yeah, there we go. All right, so, okay, good. Don't know how some of this stuff happens. So we can rewrite this, C of Q, 0.13, for Q on 0 to 330. Okay, so now let's distribute the 0.15 in the second formula and then combine like a point or slope intercept form. So $42.90 minus 0.15 times 330 is negative 6.6. So the second one is 0.15 minus 0.15 Q minus 6.6 for Q on 330 to 429. Now that looks weird, right? 0.15 Q minus 6.6. What's going on there? Well, the minus 6.6 has a simple physical interpretation. Let's say your bill's exactly, oh, I need a 0.13 Q here. That would be useful. Let's say your bill's exactly baseline, exactly 330 kilowatt hours. 0.15 Q is charging you 15 cents per kilowatt hour for all of your kilowatt hours. Right? But your first 330 kilowatt hours, it's charging you 2 cents too much, so then you have to subtract this off. So this is the 2 cents extra that was being charged here on your first 330 kilowatt hours. So you're subtracting off that extra. If you plug in 330 into this equation, you get the same thing that you get if you plug 330 into that equation. So they match up. The next one is going to be 0.32 Q. Now note that for your first 429 kilowatt hours, you're being overcharged, so we need to subtract something. And we're going to subtract 57.75 minus 0.32 times 429. So we're going to distribute in the 0.32, 57.75 minus 0.32 times 429, so minus $79.53. 660. And then the fourth formula, 36 cents times Q minus, okay, 131.67 minus 0.36 times 660 is minus 105. So this $105.93 is basically how much you would be overcharged if you build the first 660 kilowatt hours at the 36-cent rate. You're basically come up with an overbill of $105.93. So this corrects that. And so, of course, these formulas, if you just want to publish a brochure or a guide or just have them for reference, these are easier to work with than those because, look, you have to do the parentheses and do the subtraction. I haven't got thrown off on the one myself. Here, like if your electric bill is, let's say C of 528. Let's say you use 528 kilowatt hours. Okay, we look up which interval we're in. Okay, 528 is within here, tier 3. So we just plug 528 into this equation. 0.32 times 528 minus 79.53. $89.43. So if you used 528 kilowatt hours, the bill's $89.43. That's how you compute it. So you just look up to find, okay, first of all, 528, where am I in, which tier, and then I look up and use the formula for that tier. So that's how we used piecewise linear functions to come up with a single, it has different structures here, but this is really just a single equation to tell you what your electric bill costs as a function of how much energy you used. First you look up, well, where is that amount of energy on the domain, and then you use the corresponding appropriate formula for that amount of energy. So that's kind of the power of these piecewise defined functions, is that you can do things like this with different structures and different tiers and all that sort of thing.